All right, guys, today we're going to be talking about the thermodynamic aspect of corrosion. So today we got to refine, so before we start all this, we got to define our terms. What is Gibbs free energy? Gibbs free energy is basically the universe wanting a lower, more stable energy state, okay? So think of your room, for example. Your room naturally, like as time goes on, like let's say if you lived in your room for a week, your pillows would all get messed up, your shirts would be on the floor and everything, your blanket would be all messed up, right? That is spontaneous. That's just more spontaneous. That's what happens, um, just naturally, right? That's just what happens naturally. But when your room is all organized, your bed is made, your clothes are organized, it takes energy. It takes energy to make things more organized. So that is higher Gibbs energy. So in the real world, right? Iron doesn't come already shiny. It comes from the ground, all rusty, all like from an ore. It's got low energy. So we have to pump lots of energy and material to really refine it to make it shiny, like we know, shiny iron, right? So doing this, it gives iron a higher energy state. And in second law of thermodynamics, once again I said things move to a lower energy state. So yes, let me see my notes. So yeah, all in all, the universe basically it literally wants your tools to turn into rust again. It wants it to turn back into the low energy state it is. But if the universe like wants things to turn back to rust, why doesn't it happen instantly? That's when kinetics come in. Kinetics is like the rate of reaction, how long it takes for the universe to turn things back spontaneously. And an example of that could be like in corrosion can be like um, how iron turns back to rust. In a hot environment like Arizona, where it's dry all year, it could take years for iron to corrode. But in like a wet Pacific salty water environment near the ocean, like I don't know, near the ocean, it could just take days for iron to rust. So another thing, why do metals like aluminum, which have a stronger thermodynamic drive to corrode more than iron, survive just fine? Why does aluminum survive better than iron when aluminum wants to corrode more? Basically, aluminum forms an invisible protective oxide layer that prevents further reaction. And I like to think of this like a pear. Imagine a pear with like perfect unbroken armor, like the skin, where no oxygen can mess with the inside and the inside will always stay fresh. That's how what aluminum has. While iron, on the other hand, is really flaky and porous, and as soon as the first layer goes, it'll be shiny on the under it, and then the layers just keep going, and it's more shiny, 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 and then every droplet of water creates like a battery to corrode um, until there's nothing left, and that's the electrochemical process of that. So another way we can fight corrosion, which is what the world is about, right? Fighting corrosion, we don't want it to happen, is a thing called sacrificial anode. Sacrificial anode is basically in its name. Anode is the site where corrosion happens. It's where metal gets eaten up, and the sacrifice part is by adding another metal so that it can get eaten up while protecting the metal we're trying to protect, right? So let's say a ship, for example, right? The ship is like steel. We stick like zinc, a layer of zinc, and then here's a water. We stick a layer of zinc between the steel and the water, so that the water can eat up the zinc first before it eats up uh the steel. So, but why zinc though? Why out of all the materials zinc? So when you dip metals in water, we see how strongly the metals hold on to its electrons, right? For example, gold really holds on to the electrons really tight. But zinc, when you dip it in water, it doesn't hold on to electrons that tight. It doesn't have that attraction to it. And that attraction is called voltage. In water, oxygen really wants to grab those electrons because oxygen has to fill in those shells. But anyways, the attraction of metal, the attraction of how metal has to its electrons, that's called voltage. And the lower your attraction to the metal is, the more negative your voltage is. So the more negative stuff is what you want as your sacrificial anode. So oxygen can take the metal. Um, uh, so oxygen can take metals that have like looser electrons. That's what corrosion is all about. So yeah, remember next time, corrosion isn't a flaw, it's just physics. Metals are just trying to go back home. So thank you for listening to my video once again. I kind of jumbled it up at the end, but I think it went good. Thank you for watching.